Okay, in this video, we're going to get into section 2.2, which is all about graphs of functions, and in particular, functions in which the domain and range are subsets of the real numbers, because it doesn't really make a lot of sense to talk about graphs with where the coordinates are not real numbers. So we want to stay in the Cartesian plane, so we require this. And in this case, then the graph is just the set of points in the Cartesian plane, or in the xy plane, where y is always f of whatever the x coordinate is. Okay, so another way of thinking about this is all the points where the x coordinate is x and the y coordinate is f of x, and x includes all the numbers in the domain. And so the domain of f, in this case with respect to the graph, the domain of f is all the x coordinates of the points on the graph, and the range of f is all y coordinates of the points on the graph. And there's a very simple way of, if you see a set of points or a line or a curve in the plane, we'd like to find if that is describes a function, or specifically if y is a function of x. And the way we do this is we have this vertical line test, which says that a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph at most once. Okay. And we can sort of see why this is true, because if we take a graph, or if we set a set of points that we think might be the graph of a function, we can see that in this case we can't, this obviously would not cross the vertical line test, or pass the vertical line test, because we have these 2 points right here that lie on the same vertical line. And what that means is that if this, let's say if we said that this was the function, the graph of f, say, and let's say this was -2, then the coordinate of this point would be -2, say g of -2, and this would be -2 g of -2, and we can see obviously these points have different y coordinates. Okay, so g of -2 can't be two different values. Right? That's the main requirement for something being a function. Okay, there's only one possible output for -2. Okay, so that's why if it's a vertical line, if a vertical line crosses it more than once, then it's not the graph of a function. Okay, now interpreting these graphs aren't too bad if you just understand the notation. So if I give you a graph of this function f, we can see this is clearly a graph of a function. It clearly, every vertical line intersects it at most once. And we want to find what these values are. Well, we just look at we're given the x value, and we want to look at the corresponding y value. So for f of 3 is just the y coordinate when x is 3. Okay, so we look up here for a point where the x coordinate is 3. We see the y coordinate is 4, so f of 3 must be 4. Okay. What about the point where x is 0? Well, that's this point. It's the y-intercept, and we can, this point, of course, is 0, 2, so the y coordinate is 2. F of 6, we can see that 6 is it's the x-intercept, so this is the point 6, 0. So in this case, the value of f of 6 is 0. And f of 7, we look at that corresponds to this point. The y coordinate is -2. So then the domain of this function corresponds to all the x values, or the x coordinates on this graph. And we can see that this graph runs from x equals -5 to x equals 7. And we can see that if we pick any number in between between -5 and 7 and look at the corresponding vertical line, it will intersect that graph. Okay, so that's a way of checking is this in the domain. Okay, because there's no number between -5 and 7 which gets left out. Okay, so the domain of f is just the closed interval -5 to 7. It's closed because we are actually there is indeed a point. -5 is in the domain because there indeed is a point where the x-coordinate is -5, and similar for 7. Okay. The range corresponds to the y-coordinates. Okay, we can look and see that the highest point is at 3, 4, where y equals 4. The lowest point is at this point, 7, -2, so y is -2. So we can see the largest value of f of x is 4, the smallest value is -2, and we can see if we take any number between -4, between 4 and -2, and look at the corresponding horizontal line, that will intersect the graph at least once, right? So that is, if we take any number between -2 and 4, there's going to be at least one point on this graph whose y-coordinate is equal to that number. So the range is the closed interval, -2 to 4.